Today we're going to combine what we know about radicals and exponents and put them together. So the first thing we're going to talk about is finding the nth root. So the nth root means we're going to have a number instead of, the square root has to do with, you find two of a kind. The nth root, we're going to have to find the fourth root, the seventh root, the 12th root. And it's a pretty easy situation. So let's start right away with our examples. So we're going to find the third root or the cube root of 64. So doing what we have done in the past, we're going to do our prime factorization of 64. So I'm going to have, 8 and 8. I have 2 and 4. I have 2 and 2. And then I just bring down all of that for the other as well. Okay, so we do our prime factorization. Then I, as before, get rid of all of my numbers that are not prime numbers, just so I don't have to look at them. Okay, so we start off with prime factorization as normal. Now I'm going to go back to that root that we have. It's the cube root. There's a 3 there. Okay, so that means we are going to find 3 of a kind within our prime numbers, and that's going to help us find our answer. So I see that there are 3 2s. And then another grouping of 3 2s. So that means I have one grouping of 2s times another grouping of 2s, and that gives us 4, which is our answer. So if we were doing something to check our answer, basically we just have to do 4 cubed, which is the inverse operation of the cube root, okay? So 4 cubed is 4 times 4 times 4, which is 64, so we know our answer is correct. The answer for the cube root of 64 is 4. So the next one, we're going to start out the same. For 81, we're going to do prime factorization. So I have 9 times 9 is 81. I drop it down to my 3's, to my prime numbers. And I cancel out my composite numbers I don't need anymore. So just as we looked at before, we're going to look at what root we're doing. It's the fourth root, so I'm looking for 4 of a kind. This one was kind of simple. That means all of our 3's. So we have 4 3's, so the fourth root of 81 is just 3. And again, to check your answer, you do 3 to the 4th power. So that would be 3 times 3 times 3 times 3. Okay, so it's basically 9 times 9 if you simplify it, which is 81, and it's correct. But you're just looking at what your root number is, and that's how many of a kind you are going to find. Go ahead and simplify all of these roots to prime factorization, and then find out what your answer is. So you're going to have the 5th root here, so you're going to find 5 of a kind. We have the cube root again, so 3 of a kind. The 4th root, and then the 5th root. So go ahead and put it all down, try to find your answer, and then pause the video. Come back and see if your answers are correct. All right, so here are the answers I received. We have 2, then 6, then 5, then 4. You guys can feel free to look at my work, see how you did it, see if something's different that we had to do. But those are the answers for the various roots. Now we have rational exponents. Rational numbers are fractions or decimals that end or repeat. So we have fractions here, and it's a pretty simple concept to get used to, but what basically happens is we turn these fractions into a root. So you will take the denominator, and just swoop it to create your root. So 400 to the 1/2 exponent is the square root, basically, of 400. You take the same thing with the denominator to all of it. So 243 to the 1/2 power is the 5th root of 243. And then for 49, you take that square root of 49, and then you just simplify it. So the square root of 400 is 20, because 20 times 20 is 400. So the answer is 20. Okay, and obviously for the 49, the square root of 49 is 7. And now I'm going to actually do my prime factorization for 243 to find my 5th root. So 243 can be divided into different numbers. Let's see what we got. I'm going to have 3 times 81 is 243. Then I have a 9 times 9. I bring that down to 3 and 3. And you guys can already tell that the 5 of a kind we have is 3. And so that's your answer there. So you just turn that denominator from the fraction into the number root, the nth root, and then solve your problem. Go ahead and try the next 3 on your own. Turn these exponents into the root, then go ahead and simplify your answer. Pause the video and come back to check. All right, so here are the answers you should have gotten. That last one was kind of a trick question because you can't simplify 140 into the 7th root. You can't find 7 of a kind, so that stays as is. So hopefully you got all 3 of them correct, or at least the first 2. This last one was a little difficult, but hopefully you understand why this answer is as is. Now we're going to start seeing different numerators on our fractions for the exponents. And again, it's not too difficult. So what this becomes is we change the fraction so that it becomes a singular fraction. So it's 1/4 times 3. Because I'm expanding this to make it a little simpler. So the 3 gets popped outside of the parentheses so that we have 1/4 power. And when we go ahead and swoop it, we have the 4th root of 16 that we're going to find in our parenthesis first, and then bring it to the 3rd power. Okay, so the 4th root of 16 is 2, and then when we bring it to the 3rd power, that gives us 8 as our answer. So you guys are now going to find the root of something and then bring it to an exponent. So for the next one, we have 27, and we're going to separate our fraction, so that's 1/3, but then we're going to divide that 4 out of there, so it's times 4 on the outside. Okay, so I'm just taking the numerator and swooping them out to the outside, because if I were to do 4 times 1/3, I would get 4/3. So I'm just separating them. Now this turns into the 3rd root of 27 that we're going to find first because it's in parentheses. And once we find the answer, we bring it to the 4th power. So the 3rd root of 27 is 3. And now we're going to bring it to the 4th power, so that becomes 81, and that is your answer. So now combining 2 different concepts into one. Go ahead and try the next 4 on your own and see how you do. You're going to have to separate the fraction and then find the root of the number, then put it to a different power for the exponent. Check back and see if your answers are correct. All right, so here are the answers I received. Again, this last one was kind of funky because it cannot be simplified. 78 does not have a 5th root because the only 2 numbers that are able to multiply to become 78 are 2 and 39. But then you also bring down the 39, which is 3 and 13. So you only have various prime numbers, but you don't have a 5th root. So that kind of stays where it is. And the other numbers were indeed whole numbers that you should have gotten. Now we are going to find the length and width of the bake sale sign. So basically you just have to simplify our different signs. So I'm going to start with this 4 first. So 4 to the 1/2 power, it swoops and becomes the square root of 4, which is 2 feet. So that one was pretty simple. Now the length, we have to find the 6th root, which means we have to divide this into 6 even parts of some prime number. Okay, so we're going to have I'm going to divide this by 3, and we have 243. Then I'm going to divide it by 3 again, so I get 81. Then that becomes 9 and 9, 3 and 3. So we can clearly see that our 6 of a kind is all of the 3s. So this becomes 3 feet for the length. And that's all we had to do.